Pretty straightforward today. We're talking about surface area and volume of rectangular prisms. Um, First thing, we want to differentiate between what surface area is and what volume is and what a rectangular prism is. Okay, so let's start off by saying a rectangular prism is a three-dimensional shape. Okay, it is a three-dimensional shape. Okay, which means that it's something you could hold in your hand. It's a three-dimensional object. Prisms are something we'll be talking about in general. Rectangular refers to the base. So when we say a rectangular prism, we mean here's your base, okay? And what's coming off of it is all 90-degree angles, right? So nice flat sides, right? Essentially, you would call it like a box, right? So again, you have three dimensions. You have length, width, and height, typically we call them. Length, width, and height, we call them. And there's other prisms that we'll talk about. If I said it was triangular, right? But we had nice straight right angle sides coming back from all of them, right? This would be something like a triangular prism, right? Hard to draw. I'll try that again. Triangular prism, okay? Okay. But again, when we're talking about rectangular prisms, we're just talking about essentially a box, right? And there's two things we can find out about these things. I mean, I guess there's more things, but two things that we're going to focus on today. And that's going to be surface area and volume. Now, surface area is, if you think about this as a box, how much wrapping paper would you need to cover all these sides? Essentially, what you're going to do is you're going to find the area of the 6 surfaces that make it up. Okay, so let's get you a nice, neat one here. So I got square base. We'll do square base. Remember, a square is a rectangle, so that's okay. Okay, we had a nice rectangular prism, right? Nice little optical illusion you guys got going there. Is it popping out of the screen? Is it fading into the screen? I don't know. But when we say we want the surface area, what we want is, if you see, there's a front end, a back end, and then there's 1, 2, 3, 4 sides. This is very difficult for me to show you without holding one in my hand. But there are 6 surfaces, right? There's a back side, a front side, left, the right, the top, and the bottom, right? So typically the easiest way that you can tell someone to do is like, what happens if I just kind of cut the box up, right? Well, if I cut this box up and laid it out, what would it kind of look like? And essentially what you get was, let's say we had the bottom, right? We have the bottom. And then if we kind of unfolded it, there was going to be a left side to the bottom that was attached to the bottom, a right side that was attached to the bottom, right? The top that flipped over, right? And then we kind of had a top side that was a square, and a bottom side that was a square, right? So again, those are your 6 sides if you kind of cut up the box and laid it out. When you're finding the surface area, what you're going to need to do is you're going to need to find the area of these 1, 2, 3, 4, 5, 6 different parts, and you're going to have to add them all together. Okay, so that's what surface area is. And surface area has its important meanings in life. We'll talk about that as we get a little bit closer. We need to know a little more about spheres and cylinders, and I can explain to you guys what this has to do with the Dodge Hemi engine and why it makes your potato chips taste better and why thinly sliced deli meats taste better than other stuff, okay? So we'll talk about what surface area means today. I just want to talk about kind of how we're going to calculate it, okay? So you find the area of this. What you're going to find out is that a lot of these, in this case, because you have a square base, these 4 are actually all going to be the same, and these 2 are going to be the same. So it won't be as much work as you think it is, okay? So let's take a look and see if we can get a... no, let's go ahead. I'll make you guys one. So, say for example, I got a box that's, we'll say it's, I don't know, 6 inches this way by 4 inches this way. And then as I bring it back here, okay, I tell you that it's 10 inches deep. Okay, so it's 4 by 6 by 10. Okay, if I want to know the surface area, now volume is super easy. Volume is super easy. If you guys don't remember, 6 inches times 4 inches times 10 inches. It doesn't matter what order you multiply them in. 4 times 6 is 24 times 10 will be 240 inches cubed. Right? No big deal there. You guys should know how to take the volume of the box. That's how much space occupies the inside. Surface area, though, is a little bit tricky, okay? So let's start thinking if this is 6, I know that this is 6. I know this one back here is 6, right? Well, I know that the front and the back are the same, right? So I have a 4 by 6 in the front and a 4 by 6 in the back. So we'll say 2 times 4 by 6, right? The front and the back. Well, this side I know is 10 inches long, but I also know it's 4 inches high, right? So I know that I have 2 of those, the left side and the right side. 2 times 4 times 10, right? And then I know what? I got the top and the bottom, right? Well, that's 6 inches across, and I know if this is 10 inches here, all the sides are rectangles, so it's 10 inches up here. So it'll be 2 times what? What did I say? 6 times 10. Okay? So essentially the big thing you're going to look at is this, okay? There's 3 lengths here, right? 6, 4, and 10. 6, 4, and 10, right? The same numbers we multiply down here, right? Think about the ways you can combine them. I can have a 6 and a 4, right? I could have a 6 and a 10, right? And then I could have a 4 and a 10. Those are the only 3 combinations that you can have, right? And if you noticed, I got a 6 and a 4, I got a 6 and a 4. I got a 6 and a 10, I got a 6 and a 10. I got a 4 and a 10, I got a 4 and a 10. I need a left side and a right side, a top and a bottom, a front and a back, okay? So the big thing is if you see those 3 dimensions, you're just looking for any way you can combine them, right? So 4 times 6 times 2, it doesn't matter what order you do it in, but 4 times 6 is 24, times 2 is going to be 48. Okay, again, that's inches squared, right? 4 inches times 6 inches is inches squared. This is just a 2. 4 times 10 is 40, times 2 is going to be 80 inches squared. 3 times 6 times 10 will be 120 inches squared, and now we just need to add these together. 80 and 120 is 200, 248 is going to be 248 inches squared, okay? So again, surface area in inches squared, volume in inches cubed, okay? So let's do another one. Again, I can't make this a rectangle, sorry. I got a rectangle in the front. Let's make it kind of tall and skinny this time. I got a rectangle in the back. All right, and we'll kind of say that we've got these 4 sides connecting them. These 4 edges connecting them. Okay, we put these. Okay. So again, let's just take a look. Okay, I know it turns into kind of an optical illusion here. Okay, but let's just say that this distance right here, this is going to be 2.5 meters. We'll say this is I don't know, 3.25 meters high, and that this distance down back here is 6 meters. Okay, so again, your volume. Okay, again, it's length times width times height. So what is it going to be? 2.5 meters times 3.25 meters times 6 meters, right? So again, you break out your calculator, say, hey, what's 2.5 times, oops, turn your calculator on first, man. You say, hey, what's 2.5 times 3.25 times 6? And it'll tell you that it's 48.75, okay? Again, 48.75, length times width times height. 1 meters, 2 meters, 3 meters leads me to meters cubed, okay? Now, again, the front and the back, okay? We need 2 of those, right? So for surface area. We need 2 of the front and the back. Well, what's the area of the front? 2.5 times 3.25. 2.5 meters times 3.25 meters, okay? We need the left side and the right side. So I got 6 meters times 3.25 meters twice. Okay, we're going to add those together. 6 meters times 3.25 meters twice, okay? And what I need now, at the top and the bottom, what is that? 2.5 times 6, twice. 2 times 2.5 meters times 6 meters. Okay, and again, same thing I was telling you guys before, you got three numbers here, 2.5, 3.25, and 6, okay? How many different ways can you combine those? I could say 2.5 times 3.25, that's one way. I could say 2.5 times 6, right? And the last one I could say is 3.25 times 6. There's no other ways to combine these numbers without just going backwards, so we don't need to do that, okay? So those are your only three ways to combine those numbers. You should remember you need two of each, okay? First one is here, 2.5 times 3.25, 2.5 times 6, 3.5 times 6, 3.25 times 6, 3.25 times 6. Two of each, right? So again, this one you're going to have to break out a calculator for, unless you really are a glutton for pain. So I say 2 times 2.5, 2 times 2.5 times 3.25. What is that going to be? That's going to be 16.25 meters squared. 16.25. Again, this is just a number too, right? Meters times meters is going to be meters squared, right? There's no meters attached to that too. That's just the left side and the right side. 2 times 6 times 3.25. Well, I know 2 times 6 is 12. So let's do 12 times 3.25. Again, since it's multiplication, you can multiply them however you want. So that's going to be 39 meters squared. 2 times 2.5 times 6. Well, 2 times 2.5 is 5, and 5 times 6 is going to be 30 meters squared. Okay. So let's see if we add these together. I got to take the 1 from here. So I got 40, 60, 70, 85.25. Okay. Good. And the last thing we really got to talk about is what happens if they throw in an extra word and they throw in the word cube. Okay. Well, if it's a cube, all the sides are the same length, right? So they might throw that one word in there, right? But that one word has a lot of meaning, right? If I say it's a cube, I'm telling you this is a cube. As soon as you see this word, doesn't matter how poorly drawn it is, all the sides are the same length, right? So what if I said this was 5 yards? Okay, then the volume is length times width times height, but the length times width times height is all the same thing. So all I'm going to say is 5 yards cubed, right? So 5 times 5 times 5, 5 times 5 times 5. 5 times 5 is 25, 25 times 5 is 125 yards cubed, okay? What would be the surface area? Well, since they're all the same, it's very easy. The front and the back are the same, the left and the right are the same, the bottom and the top are all the same, right? So what are you going to say? The surface area of a cube is always going to be what? 6 times the side squared. Okay, so in other words, length times width, but since it's the same thing, 5 times 5 is 25. So in this case, it's 6 times 5 yards squared. 5 yards squared is 25, so 6 times 25 yards squared. And 6 times 25 is 150 yards squared, right? So 25 on each side. So 25 here, 25 on the back, 25 on the front, 25 on the bottom, 25 on the left side, right? 1, 2, 3, 4. Where on this front, back, oh, on the top. Okay, so 25, 25, 25 on each side is going to give you 150. Okay, so anyway, give the IXL stuff a try and let me know if you guys have any questions. Thanks.